Did you know that your brain sees more than you do? Let me explain. In order for us to understand and interact with the world around us, our brain must process or make sense of what the eyes see. Information travels from the eyes through the brain, getting processed along the way. The first, most basic stage of processing occurs at a region called the primary visual cortex. Afterward, the processing becomes increasingly complex. It divides into two streams with distinct functions. The ventral stream flows along the lower region of the brain. It is often called the what pathway because processing in these regions allows us to identify what we see. The dorsal stream flows along the top region of the brain. It is called the where or how pathway because it helps us to identify where objects are and how to interact with them. The dorsal stream allows us to use vision to make precise, effective movements. One of the ways we know about these two separate streams is because of evidence from patients with very specific brain damage. Sometimes people can sustain damage to one visual stream, but not the other. One famous patient, known as DF, lost function of her what pathway in the ventral stream, but was still able to interact with objects using the how pathway in the dorsal stream. For example, she was not able to describe the orientation of a slot she was clearly able to see, but was able to reach out and insert a card into the slot. So even though she couldn't perceive the orientation, her brain could use the information to guide action. This condition is known as visual agnosia. The reverse is called optic ataxia, and it's more rare but can also occur. Damage to the how pathway in the dorsal stream, but not the what pathway in the ventral stream, means that optic ataxia patients can't use objects correctly, but can still perceive what they are. Researchers have also shown the same separation between perception and action in healthy participants by using visual illusions that make objects seem larger or smaller than they actually are. Take a look at this image. When we look at the circles, the illusion tricks our ventral stream into perceiving this one as larger than this one, even though they're actually the same size. But when we reach out to pick up a circle, even if we perceive it as larger than it is, we are able to grasp it based on its actual size thanks to the dorsal stream. Essentially, the illusion fools the ventral stream, but not the dorsal stream. This separation between perception and action in patients and healthy participants shows that the two visual processing streams and their functions are independent. That being said, in everyday life, it's rare you'd ever notice the difference between vision for perception and vision for action. The dorsal and ventral streams work together to help us perform daily tasks, and researchers are continuing to study the exact relationship between the two. So even though your brain sees more than you do, it's very good at integrating all of your vision into one seamless experience of the world and allowing you to interact with it.